Our solar system is a wondrous place with a single star, our sun, and everything that orbits around it, planets, moons, asteroids, and comets. What do we know about this beautiful solar system we call home? It's part of an even larger cosmos with billions of other solar systems.
Hi, I'm Jim Green, Director of Planetary Science at NASA, and this is Gravity Assist. With me today is Ellen Stern, the Principal Investigator of the New Horizons mission. You know, New Horizons has made a fabulous historic flyby of Pluto just 2 years ago, and now it's on its way into a region we call the Kuiper Belt, and it's going to rendezvous with a very mysterious world, further than we've ever gone before, something we all need to pay attention to so we can see what this is all about.
Thanks for having me here, Jim.
I think many people are surprised about the solar system, in fact, that it really doesn't stop at Pluto. There's something beyond it. When did the concept of the Kuiper Belt come about?
Well, the concept actually came about just about the time that Pluto was discovered in 1930. And a number of astronomers thought that perhaps Pluto was kind of the tip of the iceberg, and if we could see deeper with future telescopes, we'd discover a lot more out there. The most famous argument made for that was by Gerard Kuiper, who was a giant in planetary science in the middle of the 20th century, and it sort of stuck with his name on it. The discovery of the Kuiper Belt, though, had to wait for technology to develop, much better detectors, CCD detectors, and fast computers to analyze mountains of data. And so it was actually the 1990s before the first Kuiper Belt object, other than Pluto, was discovered. And of course, that was a much smaller body, as most everything is. Pluto's actually the largest thing in the Kuiper Belt, but it turns out, most importantly, the Kuiper Belt is dotted with other small planets like Pluto that no one really expected at all. That Pluto isn't the misfit of the outer solar system. It was kind of the harbinger of things to come.
Yeah, it's really been fascinating watching these objects being discovered. In fact, many of them are binary.
A lot of them are binary. Pluto itself is a binary. In fact, even this tiny little one that we're going after as our next flyby target may well be a binary. So that's telling us something about the original formation conditions, because we don't see binary planets down in the inner solar system. Venus isn't a binary, Mars isn't a binary, Mercury isn't a binary. Even the Earth-Moon system isn't really a binary. But in the Kuiper Belt, they're very common. So something was very different back then in that place that made this binary formation mechanism routine.
Now, when you talk about binary, you mean that both the primary and secondary bodies are so massive that they're actually orbiting a barycenter that exists between them.
Right. It pretty much means that they're like-sized objects orbiting one another.
What's really fantastic about the next step that New Horizons is taking, going to MU-69, is how that object was discovered. Can you give us a little background on that?
Yeah. We knew from the beginning when we designed New Horizons that its mission was to go on exploring after Pluto deeper in the Kuiper Belt. And we put the fuel on board and the communications capability on board. And we designed the cameras to work even further from the sun, so forth and so on. And then after we got launched, we started using the biggest telescopes in the world to look for possible targets. And although we found many, none were within our fuel reach. And as we started getting closer and closer to Pluto, I got kind of worried that we just weren't going to be able to carry it out from the ground. And so we asked for NASA's help, and the help came in the form of the Hubble Space Telescope, which spent a good bit of time in the summer of 2014, the year before we got to Pluto, scanning the region behind Pluto where New Horizons would be headed next to find targets. And we found several, and MU-69 was the most easily reached of that group, and that's what we're bearing down on next.
What's really fascinating that happened this summer was, of course, the opportunity that MU-69 would pass between us and stars, at distant stars. And so those occultations occurred, but to me, they were unbelievable in the way you put together your teams and deployed them and actually made some unique observations.
Yeah, well, the credit really goes to the people on those teams, and they were led by Mark Bowie, who's a part of New Horizons, in doing really state-of-the-art, more advanced calculations than had ever been done before for where the shadow of something so small like MU-69 would fly across the Earth, and getting telescopes in the right place at the right time in the shadow, way down in South America in Patagonia, in the middle of the winter, in one of the windiest places in Patagonia. And it all worked out. 5 telescopes saw MU-69 make this particular nondescript star wink out. But each telescope saw it wink out for a different period of time because it observed from a little bit different location. And therefore, we could actually use those individual tracks to paint out the shape of MU-69, get its size and its surface reflectivity. The most interesting result probably is that it looks like it could be a double itself, a binary, either a contact binary where the 2 lobes are actually touching, or 2 objects in orbit around one another like Pluto and Charon, but on a much tinier scale.
Is there another opportunity where we could catch it in another occultation?
There is another one coming next August across some pretty rainy parts of South America, unfortunately, and some pretty dangerous parts of North Africa with a lot of Atlantic Ocean in between. So we're looking at ways to go after that. That would be about 6 months before our next flyby, the flyby of MU-69. And whether we use ships or airplanes or perhaps find some places where the weather's good enough and the local conditions are safe enough to put telescopes on the ground, we could learn a lot that would help give us some more advanced warning about what we're going to find when we get there at the holidays 2018.
You know, what also amazes me is how bright MU-69. In fact, it's magnitude 27. And for those astronomers out there, that means there's no way in heck any Earth telescope would be able to see it. So it's really one that had to be found by Hubble.
It's true. Only the Hubble, because it's above the atmosphere, could do it. And we, even after we found MU-69, knew exactly where to look, would look with very large telescopes like the Keck and the Gemini telescopes and others, Subaru, and they've never spotted it from the ground. In fact, the only time it's been spotted except for Hubble was in those occultations.
Just a few photons.
It's extremely faint. 27th magnitude means that it's almost 10 million times fainter than Pluto, which itself is 1 million times too faint for your eye to see. It's just mind-boggling.
Yeah, to me, this was clearly the greatest occultation captured that we've ever done on this planet.
It was a major breakthrough. What Bowie and his team pulled off was a master stroke in not only prediction but execution, and they made it look easy. It was not. It was really beyond the state of the art until they did it.
You know, that really tells you what it takes to put together a team of talented people and let them do their work, you know.
Yeah. And I was on 2 of the occultation expeditions, and, you know, folks were working 20 hours a day in very harsh conditions in the cold, in the winter, and the wind, and nights and weekends, and they were all very highly motivated to do it, and they pull it off.
You know, how that must have gone in terms of being able to put out an array of telescopes. You know, I think you had something like 24 telescopes in a line.
We did. We set them up like a fence line, perpendicular to the path, so we would catch our prey, even if it was a little north or south of where we were going to be. We got lots of help from the locals, the Argentinian locals, the national government, their space agency, CONAI, as well as the governor and the mayor of the town that we were in. Gave us all kinds of support, ranging from police escorts to blocking the highway so that the trucks wouldn't come down with their bright headlights and ruin the observations, weather support, first aid. They really bent over backwards to help because, you know, they found out NASA was in town, and to them, that was really something to be a part of. That NASA brand was what did the trick. That, and one very helpfue translator named Adriana Ocampo.
Yeah, she's a rock star down there, that's for sure. Fabulous scientist that had worked on Chicxulub and the extinction of the dinosaurs. But, out of the 3 occultations, 2 we caught on ground, but 1 we had to do something else with.
Yeah, one of them was over the ocean, and there are no observatories floating around in the ocean. So we took NASA's biggest airborne observatory called SOFIA, and it was being based for the summer down in Christchurch, New Zealand, to make observations of the southern sky. And we were awarded time to go fly it up to the occultation path several thousand miles north near Tahiti. And I was on that mission as well. We flew 5 hours out of Christchurch north, did a U-turn and came back. And just as we turned south, the occultation event occurred, and then flew all the way back to Christchurch with the data. And here's this big lumbering 747 with a telescope the size of Hubble inside of it, looking out of a door, a hatch in the side, flying at 45,000 feet, with a flight crew and a telescope crew and the science crew. And, they were so on target that they were less than 5 wingspans off target at the exact moment of the occultation. And it's an amazing accomplishment.
Yeah, it is amazing. Unbelievable. So with all the data in hand, you're getting a picture of perhaps it being a binary. Mm-hmm. What about debris in the area? We're always worried about the safety of our spacecraft as we fly through.
Yeah, and we're worried primarily because we're going so fast. We're going 10 miles per second. And so even if you hit something small, it's a very powerful wallop. And there's basically no good place to hit New Horizons. If you do computer modeling of that, anything, even a rice pellet that hit the spacecraft will cut a fuel line or take out a circuit board or destroy an instrument or what have you. So we're trying to certify the path as best we can. And the occultations help us with that, because before and after you occult the hard body itself, you can look for dips due to rings, dips in the light due to rings, or other debris structures that could be in orbit. And unfortunately, we didn't find any. So that tells us that some of the worst disaster scenarios that could be out there aren't out there at MU-69. They might be somewhere else, but they're not at MU-69. But still, we have to look even harder to certify the path on approach. We'll do that with our own telescopes on board and our own cameras on board by sending that data back to the Earth throughout the fall of 2018. And we'll be scrutinizing those images as best we can. And if we find anything that's concerning, we've planned an entire backup flyby at a greater distance, which is presumably safer, to give ourselves some options for still getting good data, but avoiding danger if it's in our path for the very closest approach.
I'm Jim Green. I'm here with Alan Stern talking about the Kuiper Belt and what's next for New Horizons. One of the things that I always wondered about is our comets. We get comets from very far away from the Oort cloud, but there's got to be comets coming out of the Kuiper Belt too. So what do you think the relationship between what we have, Pluto-like objects, and comets are?
Well, that's a really good question. We know that comets, the short period comets, come from the Kuiper Belt. And we know that we've seen quite a number of those up close with spacecraft missions now. Rosetta recently orbited one for 2 years, but we had various American and European spacecraft fly by comets, also some old Soviet spacecraft that flew by comets in the 80s. They don't look anything like planets. They're small and lumpy, and they don't have the geological processes that big worlds like Pluto, that's would basically span the United States in diameter, have. And also their composition turns out to be quite different. We see on the surface of Pluto much more exotic ices than we see on the surfaces of comets, things like nitrogen ice that are very rare in comets. And we see a bound atmosphere that we don't see around comets. So just like the asteroids and the Earth are different, the comets and the small planets of the Kuiper Belt are very different, but they're all teaching us about the origin of the solar system and about the types of objects we can expect to find around other stars. And so it's all part of the basic exploration that we do as we open up the solar system to space travel.
New Horizons, after it flies by MU-69 in January 1st, 2019, and I know where I'll be when that occurs.
Me too.
But it's heading out. It's heading out of the solar system. Is that going in the same direction that the Voyagers are?
It is going in roughly the same direction as the Voyagers. And like the Voyagers, it will escape out into the galaxy.
Now, it has radioisotope power, and that will last for a considerable length of time past MU-69. Do you think it can make it to the heliopause?
Well, that's a good question. We have a lot of Kuiper Belt work left to do before we get to the heliopause. The heliopause is probably 100 astronomical units out. And if you, if you calculate the amount of power that we have on board, we could still be operating then. It'll be in the mid to late 2030s. The thing about the heliopause, and I know you know this, Jim, is that it breathes in and out with the solar cycle. And sometimes it's further and sometimes it's closer. And although we can predict exactly where New Horizons will be in any given year, no one knows how to predict those solar cycles. So it's hard to know in the 30s if the heliopause will be farther and we run out of power before we get there, or if it's closer and we cross it out into interstellar space. That's part of the excitement of that part of the mission that'll come, after the planetary science is more or less done, which will probably be in the 2020s. And that will be a very valuable mission scientifically because the instrumentation on board New Horizons is a generation more sophisticated than Voyager could carry. So we can learn new things about that whole region of the solar system with these much more sensitive instruments.
And one of the things that New Horizons is doing between now and when it flybys MU-69 is really looking at other Kuiper Belt objects. What do you hope to achieve by doing that?
Well, we're trying to put MU-69 in context. We're going to swoop down on this one and study it with this spectacular battery of instruments and get all this detail. And the question is, how do the other ones look in comparison? What are their shapes like? What are the numbers of satellites they're like? What are their surface properties like compared to MU-69? So we're actually looking at dozens of others with our telescope camera called LORRI on board. And not just before MU-69, there are a lot of them to look at after MU-69 because the Kuiper Belt doesn't run out. It actually turns into what's called the extended belt or the scattered belt that goes out actually hundreds of astronomical units. So it's all about context and making sure that we understand this valuable data set at MU-69 compared to all the other things out there in the Kuiper Belt.
The science is just spectacular. We're just pushing the limits of what we know about the solar system and making new discoveries every day. And, I always ask, what was your gravity assist? What really got you excited about what we're doing today?
Well, I've had a number of gravity assists in my life, but I want to tell you a very special one that occurred just a few weeks after the New Horizons flyby. I was in Vermont at a convention of amateur astronomers in August of 2015, and after my talk was over and most of the crowd had dissipated, there was one who had said, I'd just been waiting and waiting to just come up and tell you something. She said, people often say that our generation missed the boat on history, that we didn't see a great world war, the great world war that triumphed over evil. And we didn't have a chance to see the moon landings or the birth of the computer revolution that we all live with now, and so many other things. And we often hear the meme that we came too late for all those historic things. And she said, I just want to tell you, New Horizons is the best thing that's ever happened in my lifetime. And wow, what a gravity assist for a scientist.
Yeah,
to hear something like that when you're a physicist and a planetary scientist who works on the research aspects and the technical aspects, and to hear that you could change people's lives with the project that we did, and that those of us on New Horizons could actually inspire someone that way, that was my gravity assist. And it's going to power me for the next 30 years to do more exploration.
It's just been fantastic having you here talking about the Kuiper Belt and what will New Horizons do next. I really appreciate it. Thanks so much for coming.
Thank you, Jim. Anytime.
Join us next time as we continue our virtual tour of the solar system. I'm Jim Green, and this is your Gravity Assist.